In Chapter 5, we're going to look in a lot more detail at molecules and compounds. Remember, a molecule is made up of two or more atoms chemically bonded together, and a compound has to be two or more atoms of different elements bonded together. And when you're looking at a compound, compounds have the same proportion of their elements in a sample. So for example, if you find methane, you will find when you analyze it that there are 12.01 grams of carbon for every 4.04 grams of hydrogen. And if we set up a ratio, we could do a ratio of either carbon on the top or hydrogen on the top, and I'm going to choose to put the carbon on the top. 12.01 grams divided by 4.04 grams gives us a ratio of just under 3, 2.97. By itself, that ratio may not be very useful, but every sample of methane, regardless of its source, will have the same ratio of carbon to hydrogen. And nowadays we know why that is. That's because every molecule of methane is made up of exactly one atom of carbon and 4 atoms of hydrogen. Now you might think that that's backwards because there is much more carbon, almost 3 times as much carbon compared to hydrogen. But this is telling us that a carbon atom and a hydrogen atom have different masses. You remember that from the atomic mass. The atomic mass of carbon is much heavier than the atomic mass of hydrogen. And the way that we write this as a chemical formula is we write the element and then the subscript is the number. So we have 1 carbon atom and then we have 4 hydrogen atoms. And just like when we were doing charges, we don't include the 1 subscript in the formula. So we would drop that and just write CH4. That is called the molecular formula of methane. It shows you what atoms are involved in the bonding that make up methane. It could be much more complicated. You could have a compound such as this one. And later on in this chapter we'll learn how to name a compound like this correctly. So this can be read in a number of different ways. The parentheses around the NH4 and then the 3 tells you you have 3 units of this NH4, which we'll learn later on is called the ammonium cation, and we have 1 unit of PO4, which we'll learn later on has a charge of -3. The NH4 has a charge of +1. We could also look at this formula and figure out the number of atoms of each type. So 3 units of NH4, this 3 subscript acts on the subscripts within the parentheses. So there's an understood 1 subscript multiplied by this 3 tells us there are 3 nitrogen atoms in every molecule of this compound, which we'll learn later the correct name is ammonium phosphate. The 3 also affects the subscript 4. 3 times 4 is 12, so we have 12 hydrogen atoms. There's only 1 phosphorus atom, and there are 4 oxygen atoms. So this molecule is made up of these units, which we're going to call polyatomic ions because they're made up of more than 1 atom, polyatomic. But we could also look at how many atoms of each type we have.